Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the chat box if you are ready to start new chapter of class 12 NEET, that is chemical kinetics, right? It is actually one of the most easy chapter, right? Why I'm telling it's easy? Because it's also very scoring, right? Easily you can expect around 2 to 3 questions like minimum from this chapter, and the questions are predictable, they are very easy, right? You can easily see, we can complete this chapter in 3 days, right? This is first day. Within this week we'll be able to finish this chapter, right? And you can expect around like 12 to 16 marks out of this chapter, so that is a great thing. And you know what, the topics, the formulas, they are also very easy. The application of the formula is also very easy, so you will not have any problem in that, right? Okay, so everybody, let me know in the chat box if you are excited for this lecture. Everyone in the chat box. Yes, students, everybody. Yes, Sri Devi, Zoro, Adina. And wait a minute, let me see other students as well, right? Adina, Shivraj, study. Very, very, very good evening. Very good evening. Zoro, Adina, then you have Shivraj. Very good. So let us start this lecture. See, this first chapter, that is solution, we have completed it. Now, I want all of you to answer me in the chat box. Do you want DPPs of solution chapter? Right? Do you want one DPP of around 20 to 30 questions, right? Important questions of your solution chapter, so that while you are doing chemical kinetics, you can also practice the questions of solution chapter, right? If you want the DPP of every single lecture, then also you can let me know. If you want DPP of like, ma'am, you have completed this chapter, now we want DPP for that chapter, I'll also make that. So whatever is your opinion and whatever is your choice on that, you can let me know, because see, we want to crack NEET, right? This is what you want. That is not possible only through theory, only just me solving the questions. For that, we need your practice. We need that you also solve the questions yourself, right? And the questions not random, but the questions that are asked in the exam, that are useful for you, that a teacher only can tell you. So that's why if you want DPPs of every single chapter, you can let me know in the chat box. I'll definitely do that, right? Okay, yes. Now, let's start this. Hi, Ezinath, Kirtani. Yes. So let us do that. Let us do that. Now, students, if you see this, right, only one student has done the homework, right? Rest of you don't do the homework. So that's why what you miss is practicing questions, right? So, okay, it's fine that you have missed on homework in the past, in the first lecture. That's fine. Like in the first chapter, you have missed homework. That's fine. Okay. But now you still have time to improve, right? You have time to improve your mistakes. So that's why promise me that from this chapter, we are starting this chapter, you have to promise me that in this chapter, daily homework you will do, right? DPPs that I'll share, you will also solve those DPPs, right? I'll share the DPPs of every single chapter, that also you will solve, right? You have to promise me that. Ma'am, notes please provide me, ma'am. Shivraj, don't worry, the notes are provided over here, right? Wait a minute, let me just, wait a minute, wait a minute. Let me just show you where you can see the notes, right? Guys, over here, no? Over here in the description box, right? In the description box here, like after the end of the lecture, right? Over here, the notes will be uploaded, and even in the comment section, the notes will be uploaded of each session, right? So don't worry about that. You can get your notes in the description box, right? Okay, yes. Now, let us start chemical kinetics, right? So, chemical kinetics means the study of speed. So, there are different things in physical chemistry. We talk about thermodynamics. In thermodynamics, we study Gibbs free enthalpy, which tells us feasibility of the reaction. Is this reaction even feasible or not? Is this going to happen or not? That is about thermodynamics. Then we study equilibrium. We see that this particular reaction can give us how many products, right? What is the extent of the reaction it can go? That we study in equilibrium. Similar to that, we have chemical kinetics, in which we study the speed aspect of a reaction. We are going to talk about the speed, the rate of the reaction. That is all about chemical kinetics. So in chemical kinetics, we will talk about rate of reaction. In layman language, we can say speed of the reaction. In chemistry language, we say rate of the reaction, but it is one and the same thing, right? Now tell me one thing, like when I talk about in physics, what you call speed? What is the formula of speed? Speed is equals to distance by time, right? Now in this also, if we want to calculate the rate or speed, here distance is the concentration. How much concentration is used up in the reaction? How much concentration of product is formed in the reaction? Here, instead of distance, you will write concentration divided by time, right? So rate is nothing, but that is concentration divided by time. Now, depending upon that in per second, if I talk about in 1 second, how much concentration is changing, right? You will have the rate of the reaction, right? Either the concentration will go very fast, that means it will change very fast, or it will be very slow, or it will be moderate. So based on that, you have three category of reactions. First is fast reaction, that is moving very, very fast, that is happening within seconds, right? Second is slow reaction, that is very slow, right? And the third one is moderate speed, right? And here we are definitely not going to talk about fast reactions that occurs within like nanoseconds, because the reactions that are very fast, right? It's like if something is very fast, it's like in a blink of your eye that is changing, right? You can't pause it and study it, right? So that's why studying a very fast reaction is very difficult. So in chemical kinetics, we are not going to talk about a very fast reaction. We are also not going to talk about very slow reactions. Slow reactions means like you have, let's talk about carbon dating, right? Let's talk about degradation of bones, right? This does not occur within 1 day or 2 days, right? It is a process of years and years, 10, 20 years, right? Something is degraded, right? Now, because of this degradation is happening at a very, very slow pace, right? So that is the reason we are not studying it, right? Now we will study in chemical kinetics only the moderate speed. That is not very fast, it is not very slow, we can easily study it, right? These are the reactions that we are going to study. Examples are like, examples from our daily life is, for example, I talk about juices, right? Now, tell me one thing, right? You have bought a like packet of fruit juice or something, but on the other hand, you have made fresh juice in your house, right? Tell me one thing. If you make fresh juice in your house, do you like, okay, I'll drink this after a week? You don't say that, right? You don't even drink it on the next day, right? Why? Because that fruit juice, which does not have any preservatives, right? That does not have any preservatives to take care that the bacteria should not degrade that fruit juice, right? So for that, the rate of reaction of decomposition is quite fast. So when we add preservatives into it, we slow down the rate of reaction of that decomposition, right? We don't want any bacteria to act on it, right? So that we want to have to drink fruit juices which are maybe 1 month or maybe 15 days old also, right? How we can drink it, why we drink the juices, the even milk, right? even in that they add preservatives, right? That's how we can drink it after 2-3 days as well, right? Otherwise it's not possible, right? Similarly, if we talk about breads, right? Now you have bought bread, right? Now, why we always say that, oh my God, when there is hot temperature, when it's very warm outside, right? What you do? When there is cold outside, then you can keep the bread outside as well. But when it is very warm outside and you keep your bread not in the fridge, what will happen? Something like this will happen. The yeast will act on it, right? It will be decomposed, right? So that means the rate of decomposition is very high in higher temperatures. So that means, can I say that when the temperature is high, rate of reaction is high. Here we are talking about decomposition. And when we keep this in like freezer, right? Now in refrigerator, what happens? In refrigerator, we are actually making the temperature low, so that rate of reaction also decreases. So these are some of the examples in our daily life that we do. How many of you have like observed this in your daily life? There are so many things. We try to keep the vegetables, everything inside the refrigerator, not outside. If it is winters, it's very cold outside, then we can keep it outside. Otherwise, we try to keep it inside because we want cold temperature so that our things can survive for a longer time, right? Okay, so you can also tell your mom that why we actually do this. That's a benefit of taking science, right? You get to know so many things about your daily life. What is the reason behind all of those things, right? Okay, now let us see, students, here rate of reaction. What is the definition here? So as I told you, just like you have speed is equals to distance upon time, we call that speed is equals to distance upon time, right? Similarly, here we are talking about speed of a person, right? I am walking. Then you will firstly measure my distance. Then you will divide it with the time. Then you will get to know like what was the speed of ma'am when ma'am was walking, right? Now, if you want to talk about a reaction, reaction is not moving, it is not taking steps. Reaction is moving in terms of concentration. So, for a reaction, students, let me know in the chat box what we will write here. Yes, everybody, I am waiting for your comments also here. Yes, yes, tell me, Murugan. Yes, Murugan, tell me what is the doubt that you have. You can just type your doubt here and I will definitely answer that. So, if you see this, speed and rate is one thing. It is same only, right? And rate of anything is always divided by the time. Rate means that we are talking about per second. What is the criteria of defining that, right? So if I talk about rate of reaction, I write reaction like this just for the ease, right? Otherwise, it's not a proper word, RXN. It's just how I write, right? So rate of reaction is change in concentration. Change in concentration. Now here we are not talking about distance because reaction, that's why we are talking about concentration. Change in concentration divided by time taken, right? So now everybody write it down in the chat box. Rate of reaction is equals to, everybody write it down in the chat box. Everybody, rate of reaction is change in concentration divided by the time taken. That's why the definition is speed of a reaction or rate of reaction can be defined as change in concentration of reactant or product, right? Now tell me one thing, right? Reactant will be decreased or increased and product will be decreased or increased. This is in general cases what happens, right? So in general cases, right, what happens is reactant is always decreasing, right? I'll also tell you in the exceptional cases where this does not happen, right? So in general cases, the reactant is being consumed. So reactant will definitely decrease, right? And the product will definitely increase, right? Okay. What is concentration, ma'am? Concentration, you have not watched my lecture of concentration terms, na? Now just remember, concentration is the amount of solute in a solution, right? Okay, so when you have water, you add 2 tablespoon of sugar, you add 4 or you add 10 tablespoon of sugar, that defines the concentration of sugar, right? In simple way, that is the concentration, right? The amount of reactant or product that you have, that is expressed in concentration. And the general representation of concentration is nothing but that is molarity. Usually we express concentration in terms of molarity. Otherwise, there are so many concentration terms that I have taught you in a different separate lecture. You can go and visit the live sessions here and you will see a separate lecture on concentration terms. But usually we consider concentration in terms of molarity. Okay. Yes, everyone. Now, there is one case in which let me see how many of you can actually guess it. There is one case in which reactant increases but product decreases. Can you tell me what can be that case? There is one case in which reactant is like forming and product is decreasing. That is your formation of what thing? Everybody? Is it possible in real life? Yes, it is definitely possible, right? Yes. Okay, chalo, I'll explain slowly, right? So, I think I was slow only, but chalo, I'll take the pace more slowly. Now, speed is distance by time. Rate of reaction is change in concentration by time taken. The concentration that is changed. We know that usually what happens, reactant is decreasing. For example, I am going from A to B. When I am moving to this direction, the reactant, it is decreasing and the product is increasing. That is what is happening, right? So the change in concentration of reactant or products, that is defined as the change in concentration divided by time. That is your yes. In the backward reaction, no. This is actually in the formation of bacteria, right? Or you can say, for example, right, this is actually linked to your biological processes, right? This is linked to your biological processes in which what is happening that you have some bacteria here. You know, in our body, some bacteria, they develop on themselves, right? So, for example, there is yeast, right? It is developing here. So, in this case, the reactant is actually increasing. Reactant side is increasing, right? So, whenever you have in biological terms, right, you have yeast or any bacteria that is developing or algae that is developing, that is the process in which reactant is itself increasing, right? Okay, these are the processes in which reactant increases. Okay, let me know here, is there any problem in understanding what is a rate of a reaction, right? Have you understood what do you mean by rate of a reaction, right? If that is clear to all of you, then let me know in the chat box so that we can proceed with the next thing here, right? Now, rate of reaction can be expressed in two terms. The rate decreases in concentration of any of the reactant. The rate increases in concentration of any of the product. What do you mean by this? See one thing, because reactant concentration is decreasing, right? When you are moving from, let's say this is reactant, this is product, we know that reactant concentration, this is the general thing that I am telling you. And we are going to talk about general things only, right? So whenever there is decreasing of the reactant and products are increasing, right? We know that here what is happening, rate of the reaction is decreasing here, right? Why this happens, let's see that. Okay, so I'll tell you why this happens. Just give me a second. Wait a second. Yes. Wait a second. Now I'll tell you some important terms here, that why we are saying that rate of the reaction is decreasing. Okay. For that, you have to understand this concept. And this is one of the very, very important things that we usually skip, but they are important throughout your chemical kinetics, right? See one thing. First thing is I am going to talk about reactant is decreasing. Okay. In this side I am writing reactant is decreasing. This side I am writing product is increasing. This side I am writing product is increasing. Right? That you are clear now that why reactants are decreasing, why products are increasing. That you are clear with. Reactants are decreasing, products are increasing. Now let's see this. Very, very important point. Very important. I'm saying that you have change in concentration by time, right? By change in time. That is your rate of reaction. But what we do is, if you have, let's say the reaction is A to B, this is AA, this is BB. Or you just write A to B. Here also it is A to B. Right? This is the example. Now, in this case, in terms of A, in terms of reactant, how do you write your change here, right? So that will be written as minus of change in A divided by time taken, But in this case, it will be written as, rate will be written as positive of change in B divided by time taken. That means whenever you have reactants, in terms of reactants, we put minus here. In terms of products, when I am talking about in terms of product, I have to write. I put positive there. So now, ma'am, why so? What is the reason behind that? Why we are putting here negative? Why we are putting here positive? That you have to understand, right? Now, I'll tell you the reason behind that. Ma'am, what is the reason behind that? Okay, so let's understand the reason that why it is happening here, right? Okay, now let's understand the reason behind that. Why negative and positive? That is the question, okay? So I'll give you one example here. Let's say this is A and this is B. This was the reaction that we took. Same reaction I am taking here, A to B, right? Now, I'll explain you this with the help of some values, okay? Because with values, it will be more clear to you. Let's say initially you have this is 10, right? And this is 0. Because initially there will be no product, right? Now, let's say it is decreased to 5. Now, it is formed as 5, right? Now, tell me what is the change in concentration of reactants? What is change in concentration of reactants? Reactants will always be, we know that change is always final minus initial. Change is always final minus initial. Throughout chemistry, you will see this change is final minus initial, right? So that means here also it should be final minus initial. So can I write change in reactants, change in concentration of reactants is 5 minus 10 because this is final, this is initial. In this case, we will write change in concentration of products. Now tell me what I should write for concentration of products. Everybody, what should I write? Yes, what should I write? Here it will be 5 minus 10. It should not be 10 minus 5. It will be 5 minus 10. Final minus initial. Here also it is 5 minus 0. Right? So can I see that here it is coming out to be, here it is coming out to be negative. Here it is coming out to be positive. Right? Here it is coming out to be negative. Here it is coming out to be positive. In the reactant, change in concentration of reactant is the negative. Change in concentration of product is the positive. That is the reason when you are forming this thing here, when you are simply writing here, students, understand this, when you're simply writing rate is equals to change in concentration of reactant, because if I put negative here and then I write change in concentration, change in concentration of reactant, right, by time. Now let's see, this is also negative, this is also negative, this is also negative. So negative will make the overall rate will be positive, right? Similarly, in this case, you have rate is equals to positive. This is change in concentration of products divided by time. If I say this is positive, this is also positive, this is also positive, that means overall rate will be positive. Now tell me one thing, why can rate ever be negative? See, if I put positive here, then this will also be positive, then rate will turn out to be negative. But rate can never be negative. Rate is not possible, it's a speed. Speed can never be negative, right? Yes, velocity can be negative. If you have understood speed and velocity, speed magnitude is always like going on one direction. Velocity tells you the direction. We never say speed will be -5. Minus is defining the direction, right? Similarly, in this case, rate can never be negative. Speed, rate, they are always positive, right? They are positive quantities. So that's why I have to put here negative here. If I put here negative, only in that case, my rate will be positive. Okay, that is the reason we have this particular formula, that is rate is equals to negative of change in A divided by time taken. This is rate is equals to positive of change in B divided by time taken. Tell me if that is clear. Why in this case we have negative, in this case we have positive? Yes, Asi, Nath, Zoro, Adina, Study, then Shri, Devi, Paki, everybody. Let me know in the chat box if that is clear. Now, the second step, one thing is negative, positive, you should know. Now, let's talk about why the units are concentration inverse of time. Because that is rate is equals to concentration divided by time. So that's why we know that concentration can be expressed in atmospheric, can be expressed in bar, can be expressed in Pascal if we are talking about gases. Because whenever we talk about gases, concentration, there is no concentration of gases. Gases have pressure. That's why whenever we talk about gases, we replace concentration with pressure, right? So what you should know, that the unit is concentration per time. That means the unit of rate is, I'll just write it here. The unit of rate is concentration is, what I told you, concentration is in terms of molarity. Now, who will tell me what is molarity? Let me see in the chat box who will tell me what is molarity. This we have studied in concentration terms. That is number of moles of solute, right, divided by volume of solution in liters. So can I say this will be mole and this is liter? So can I say concentration units are mole per liter, right? This is molarity, that is concentration. There are other units, there are other terms for concentration as well, but majorly you will take in general concentration is expressing molarity, right? Okay, so now molarity is number of moles divided by volume of solution, right? Number of moles is mole and volume is in liters, so it will be mole per liter. So that means, can I write here mole per liter per second? Per second is for divided by time, and that is your units of rate, right? When we talk about concentration, that is the unit of rate, right? Now let's talk about if you have gases. In gases, this concentration term will be replaced by pressure. Now pressure can be expressed in atmospheric, in bar or in Pascal. Accordingly, you have your units, right? That is clear. Number of moles of solute dissolved per liter of solution. Very good, Adina. Paki, very good, very good. Yes, very good. So that is clear, right? Units are clear, formula is clear. Now let's move deep dive into instantaneous and your simple delta, that is for large values, large difference, right? So one is expressed in that if you have small change, or you're talking about at any instant, right? I'll show you this with the help of a graph. Okay, so you have this graph, right? Let's see this graph here. In this graph, wait a minute. This graph, yes. Now, in this graph, yes, in this graph only, this is the graph. Can you see firstly what is happening? As the time is increasing, concentration of products are increasing, right? Can you see that as the time is increasing, concentration of product are increasing? That we can see from here. Another thing is, two things you have, one is delta and one is D. Now, what is the difference between this delta and D? Okay, let's talk about that. So, if you have a large change, let's say I am talking about this particular change here. I am talking about this is the time. Let's say I am talking about this is the time, this is T1, this is T2. And you have to tell me what is the concentration change, what is the rate in this particular time. Then you will say at this particular time, rate will be equals to delta, because we are talking about products here. Whenever we talk about product, whenever we talk about concentration change of products, is it positive or negative? Yes, students. Whenever I talk about concentration of change of product, it should be positive or negative? Let me know in the chat, right? So, because here I am talking about a large change, it is written delta T, and here it is written delta P. That is nothing but P2 minus P1 divided by T2 minus T1. That is your overall this particular experience here, that in this particular change, this particular time, pressure is this concentration of product is P1. At this time, concentration of product is P2. So the change here and the change here will define the rate, right? Very good. And the rate has to be positive. So I'll write positive here, as you are saying. That is absolutely right. Okay. Now, if let's say I am talking about, I don't want a like big change. I am not talking about T1, T2. I am saying this is time T. You have to tell me at this time. Let's say I'm talking about at 10 seconds, 20 seconds, 30 seconds. That means I am not talking about a difference that between this to this point, what is the rate? No, I am saying that at this particular instant, what is the rate, right? So if you talk about at that particular instant, what is the rate? That is defined as the instantaneous rate. So that is written as instantaneous rate is written as, this is your rate of average, right? Whenever we talk about delta, we calculate the average rate, right? See, here it is instantaneous is dp by dt. You know, you can compare this with your daily life, right? How many of you know how to drive Activa, bike, or anything? Car, some people also know how to car. Ma'am also don't know how to drive car till now. So, right? Now, let me know how many of you like know how to drive a car or Activa or let's say anything which has speedometer, right? How many of you know? Now, if I ask you, right, that between HSR and Kormangla, what was your distance? What was your speed, right? So maybe at some point there will be traffic signals, your speed will be very low, right? Some point there will be like road will be completely empty, your speed will be very high, right? Sometimes there will be too much traffic, so your speed will be again very low, right? So you will take a average speed of that. So when I have fixed that between Kormangla and HSR, you have to tell me what is the distance, what is the speed that then you will take the average speed. right? Your speedometer will also tell you the average speed. That's what we check in cars also. We check what is the average of this car, right? This is what we check. That means we want to know that what is the average between this distance. So distance is now large. When the concentration change is large, we talk about average rate. But if I say that, okay, ma'am, right now I am outside Vedantu Center. Now I am saying that outside Vedantu Center, what is your speed? I am talking about at that particular instant. What is your speed? That is a very small change, right? So that's why that is called in terms of dp by dt, that defines for very small change, and delta is defined for very large change. That's why here we talk about average and here we talk about instantaneous rate. Okay, yes, everybody, clear, right? This is your rate of average and this is your rate of instantaneous, right, everybody? So why don't you guys interact, huh? I ask you something, do you know how to drive Activa, bike? No answer on that. You don't like to communicate with me? Huh? Why? Right? Otherwise, so we all will get bored. It's a long journey, beta. It's a long journey, right? NEET is a long journey. You will have to be very consistent, right? If you just come here in the class and you are like, okay, ma'am will give some knowledge and we will try to adapt it, you will get bored of me as well. You'll be like, okay, ma'am, whatever. One day you will get tired of me as well. You'll be like, ma'am, okay, we are now getting bored, right? For that, no, our interaction has to be good. For that, you should also communicate with me, right? If you don't communicate with me, if we don't laugh in the class, if otherwise the class will be so stressful that you will start you'll start skipping the classes. At this point, your energy is very high. But if we don't talk to each other, right? I don't ask you questions. You don't tell me the answers. I just come here and teach you. This anybody can do, right? But you know what is more important for you at this point? Teaching, learning something along with keeping your mind relaxed. For that, you have to interact with me, right? Okay. So I would love to see your like comments whenever I ask you something. It's not like I want to publish it on Instagram that Ramya every day. Ramya is saying, okay, thank you. Me too, ma'am. I don't even how to drive. It's not like I want to write it on my Instagram story with your name that he or he does not know how to drive, right? Why I'm asking you these questions? So that I can know you better, so that you can know me better, so that we can have a bond, so that you can have interest in chemistry through me, right? That is only possible. Otherwise, what's the benefit, guys? AI is there, right? Artificial intelligence is there. One thing artificial intelligence can at this point it cannot do is have a bonding with you, right? To understand you, right? It knows only what it knows. But we are humans. When we interact, we make a bond, and through that bonding, you actually, you know, when you like some subject, sometimes you don't like that subject. Sometimes you love the style of teaching of the teacher. Sometimes you love how you have bonded with that teacher. So that's why answering in the class, it's not a wastage of time. That is actually your brain relaxing, right? Okay. Yes. Should we practice? Ramya, how many questions you should practice? As many as possible. I would say around 30-40 questions of each subject is the minimum that you should do. Right now, that also depends that you are doing theory-based questions or numerical-based questions. Right? That also depends. Right? Okay. Yes. Okay, everybody. Now let us see. This we have already talked about. What is instantaneous rate and what is your rate? Okay. What is your rate of average? Now, if you talk about here, this is reactants are decreasing. As the time is proceeding, reactants are decreasing. So if I talk about this side, rate average, if I ask you, you're moving from Kormangla to HSR, then I ask you the speed here. What you will do, you will calculate the average speed. So that is your delta of reactants by T. Now we know that whenever we write rate in terms of reactant, it has to be negative. Okay, it has to be negative. So can I say that here I should write negative? Here I should write final minus initial divided by final time by initial time. That is my average rate. But for instantaneous rate, I will write it as minus dr by dt. Okay, this is what we know about average and instantaneous rate, right? Now, moving one step ahead of this, right? Now, students, see one thing. Till now, I have mentioned this one particular thing here. Let's say if I talk about this reaction, that is, it is A to B. You can easily write, ma'am, I want to ask you that, okay, tell me one thing. Tell me one thing. Let's say it is going from, this is A, this is plus B, give rise to C plus D. Okay. Now I am asking you what should be the rate here. You're like, ma'am, okay, rate, I have to write. Now, rate you should write in terms of reactants and product, all of them, right? So, it should be, in terms of reactant, it should be minus dA by dt. In terms of B, it will be minus dB by dt. And throughout this chapter, we are going to talk about instantaneous rate. Average rate, so we don't talk about in this chapter. You will see instantaneous rate only. So you will always see me typing here d, not delta, right? So this is minus dA by dt. This is minus dB by dt. Tell me over here, it should be plus or negative. For C, it should be positive or negative. Students, for C and D, it should be positive or negative. Let me know in the chat box. For C, whether it should be positive or negative. Yes, everybody, I am waiting for your answers. I am waiting for your answers in the chat box. Whether it should be positive. Okay, so until this, ma'am, Zoro, I'll definitely make a video on that. Right? I'll definitely make a video on that. Yes. Very good. Positive and positive, right? Okay. But what if I tell you, if you have any stoichiometries here, that means if you have any coefficients here, right, then the rate of reaction will change. How the rate of reaction will change? Let's see that. This is rate of reaction. This is rate of reaction in terms of A, B, C, D, everything here. So what I should write here, right? In terms of A, it will be minus dA by dt. In terms of B, it will be minus dB by dt because it is reactants. In terms of C, it will be positive of dC by dt. In terms of D, it will be positive of dD by dt. Now, I am saying this is actually a wrong answer. Can you tell me? Yes, right in, yes, very good, right? Now we have to divide this coefficient in the rate of reaction. So whenever you are writing the rate of reaction, it will be divided by the coefficient. It will be divided by the coefficient, right? Here, why I have not divided it with the coefficient? Because the coefficient was 1 here, right? So that's why I divided it with 1. That was the same thing only, right? So what you have to remember is, whenever you are writing rate of reaction, in terms of reactant, there will be negative. There are 3-4 conclusions here. In terms of reactant, it should be negative, negative. In terms of product, it should be positive, positive. And rate of reaction is divided by the coefficients here. You will always divide it with the coefficients. Okay? Yes, everybody. Is that clear to everybody or not? 3 conclusions we have here. In terms of reactant, it's negative, negative. In terms of product, it's positive, positive. And we are dividing rate of reaction with the coefficients. Is that clear to everybody or not? Yes, everybody. Okay, MS, Viranki. How is the experience? Just give me a second, students, please. Okay. Okay, guys, just give me a second, please. Okay. Now you have this now. Now, what will we do? Okay, now let's talk about this thing here. That rate of reaction, I told you that in terms of reactant, there will be negative, negative. In terms of products, there will be positive, positive, right? And whenever you talk about rate of reaction, you will always divide it with the coefficient. But whenever we talk about rate of appearance and disappearance, things will change entirely here. So let's talk about rate of appearance and disappearance. That is a different concept as compared to rate of reaction. Rate of reaction, we do for overall reaction, what is the rate, right? But whenever I talk about rate of appearance, I am talking about a specific thing, right? So let's talk about this thing here, that for example, you have, let's say, same thing. Okay, I'll just draw the same reaction here, right? Now, if you see this here, right, in terms of, if someone asks me, what is appearing here? Tell me, in this reaction, which thing is getting appeared? Products are appearing, reactants are disappearing. So always there will be rate of appearance of products, right? So whenever I want to write the rate of appearance, now rate of appearance will be for a specific reactant or product. Now products are getting appeared, so I am talking about rate of appearance of C, and here I am talking about rate of appearance of D. Okay. Okay, everybody? Yes, everybody? Uh, okay. Hmm. See, whenever I talk about rate of appearance, right, in that case, we know that product is positive. This will be dC by dt. This will be positive. This will be d by dt. But whenever I talk about appearance, I will not divide it with any coefficient, right? If you see, in case of rate of reaction, what you did here? You did reactants, you have negative, negative, products, you have positive, positive, right? In case of reactants and products, while calculating rate of reaction, you will always divide it with the coefficients. Coefficients are these things here, right? These are coefficients. But whenever I talk about rate of appearance, in rate of appearance, I will never ever divide it with any coefficient that is mentioned in the balanced chemical equation, right? Like you have appearance here. In this case also you have rate of disappearance, okay? So I'm just writing the same reaction here, AA, BB give rise to CC and DD. Now small a, b, c, d are the coefficients here, okay? So if you see this, if I want to write the rate of disappearance, right, of C. Here I want to write rate of disappearance of D, right? Disappearance will be not of C and D, it will be of rate of disappearance of A and B. Okay, rate of disappearance of A and B, right? Now Tell me in the chat box, should I put negative here or positive here? Should I put negative? I am talking about reactants because which is getting disappeared. Reactants are getting disappeared, right? So when the reactants are getting disappeared, that means here I am, should I put negative here or should I put positive here, right? Yes. Ramya, that is a different thing. Okay, that is rate law expression. Let's not confuse ourselves, right? So that is rate law expression, right? We will talk about that. Give it some time. Now let's talk about differential. This is differential rate law, right? In which we are talking in terms of differentiation, small d, right? That's a different thing. Okay. So whenever I talk about in terms of reactant, I want to say this should be dA or dB. So in terms of reactant, it will always be negative. That I told you in the first slide, right? So it will be negative. So now this is dA by dt and this is dB by dt. So that means, should I divide it with any coefficient here or not? Should I divide it with any coefficient here or not? Okay. Should I divide it? Ramya, first thing now, you have to let that thing out of your head. You are thinking about coefficient, stoichiometry, raised to power, right? That's why you are getting confused, right? You have to be completely present in the class, right? So I am not even near rate law expression, right? I am talking about simple thing, definition of rate of reaction. That is in terms of reactant and products. I'll just conclude everything that I taught you here, right? One thing I want to tell you is, if you have a reaction, right? There is some reaction that is given to you. They ask you rate of reaction. In rate of reaction, when you write it in terms of reactants, that will be negative. So it is minus dA by dt. This is minus dB by dt. In terms of product, that will be positive. Positive of dC by dt. Positive of dd by dt. Okay. This d is the coefficient. This d is the differential. Please don't get confused here. This is differential. This is generally we write it here. This small d is the coefficient. This can be 1, 2, 3, 4, half, 1 by 2, 2 by 3, 5 by 6, anything, right? Any number can be there. That is coefficients, okay? So, whenever we write rate of reaction in terms of reactant, it's negative. In terms of product, it's positive. And rate of reaction is divided by coefficient. But whenever you write down rate of appearance or disappearance, everything is same. It's just that you will not divide it with the coefficients. Is that clear now? Right? Okay. Is that clear now? Right? This is not rate law. Yes, this is simple rate of reaction in terms of its differential. You can say this is differential rate law, right? In terms of differentiation, how you write down when some reaction is given to you. Okay, now we will do some questions based on that so that it can get clear in your head that what I am talking about, right? By questions, it will be more clear. Okay, Ramya, right? Now let's see this. Rate of formation of nitric acid in the following reaction. So this reaction is given to you. Can you see? This particular reaction is given to you. So whenever you are solving the questions here, you have to firstly see whether this reaction balanced or not. So can you see this reaction is balanced? 4 nitrogen, 4 nitrogen. Usually if this coefficients are given to you, it is balanced only. But you can also cross check here, right? So rate of formation of nitric acid is given to you. That is this thing. Now tell me one thing. What is rate of formation of nitric acid here? Can you write it down here? Can I say rate of formation? Formation, appearance of nitric acid, appearance of product here. This is the product. So that means rate of formation, that is 3.6 into 10 raised to power minus 3 is nothing but because we are talking about products here. So tell me, it should be positive here or negative? It will be dNO by dt. Should I divide it with the coefficient or not? I am talking about appearance. Very good, Ramya. That's great that it is clear to you now. So we are talking about products. So in products, it should always be positive, right? Now, if I talk about appearance or disappearance, should I divide it with the coefficient? Should I or not? Should I divide it with the coefficient? Yes, everybody? Yes. So, should I? You will tell me. I will not tell you. You will solve this question. Okay. I'm just going to ask you questions. Let us see if you're able to solve that or not. Right? So, you should definitely divide it with the coefficient or not. You should divide it or not. No. Very good. Very good. So, I was just trying to confuse you here. Right? So, you should not divide it with the coefficient, ma'am. Yes. Very good. Right? So, that is our first equation. Can I just type yes here? Just put, okay. Rate of disappearance of oxygen they are asking you. ठीक है. Now tell me what is rate of disappearance. Rate of disappearance of oxygen means this thing. It is on the reactant side, so it should be minus dO2 by dt. This is what they want you to calculate. So whenever you have to go from this to this, always take help of rate of reaction. So rate of reaction is, in terms of oxygen, it is minus 1 by 5 dO2 by dt. In terms of NO, why am I not writing in this in terms of H2O or NH3? Because we don't even need that. That is not asked to you. So why would I write that, right? So simply write 1 by 5 O2 and this is 1 by 4. This should be positive dNO by dt. Now solve. Now you need to have a equation between this and this. So what you can write here, this is also written as, this is 1 by 4. This is given to you 3.6 into 10 raised power minus 4 minus 3, right? And dO, you have to calculate dO by dt, dO2 by dt, right? So this 5 will be multiplied here. So it will be 5 here, right? So can I write 5 by 4? So this answer is going to be minus dO by dt is going to be 5 by 4 into 3.6 into 10 raised power minus 3. You can solve this and you will get your answer for this one. Okay, right? Yes, that is completed, Nandini. That is already done, right? So that is going to be the answer for this. Is nothing but this is your rate of disappearance of oxygen, right? Okay, same things we are going to do here. Okay, you will see same thing I'm going to doing next 4-5 questions. Same thing will happen, right? So now you have 2 of O2, 2 of H2O2 give rise to 2 of water, and this reaction is given to you. They are saying rate of formation of H2. Rate of formation of H2 they have given you. Okay, so rate of formation of H2 will be what? So this is appearance of H2O. Appearance of H2O. Product side means it should be positive. So can I write positive of d of H2O by dt? This is given to you. Actually, rate of formation of O2 is given to you. Okay, so it will be d of O2 by dt. That is given to be 45 gram per minute. Okay. Now, you will say, ma'am, gram per minute, ma'am, what is this unit? You told us that it should be mole per liter per second, right? See here they have taken concentration in terms of weight, right? So to confuse you, this also they can do, right? So usually concentration in terms of molarity, that is mole per liter. But now they have given us in weight, so I'll take it in weight only. You don't have to change the units. You don't have to do anything. Simply understand one thing. Concentration has different expressions. But here they have given concentration in terms of weight, not in terms of molarity. That is the only thing that you can get out of this unit. And time they are not calculating it in per second. They are just calculating it in minutes. They can also calculate it in hours. That's totally their choice. We can't do anything about it, right? So dO2 by dt is, you just have to focus that this thing is 48, right? Now, rate of formation of H2O, rate of disappearance of H2O2, everything will be answered with the help of rate of reaction. Now, who will tell me what is rate of reaction? Guys, I want you guys to solve it on your notebooks as well, because that will be beneficial to you only, right? So if you see this here, this is going to be, when I talk about this particular reaction, I want to talk about rate of reaction altogether. So rate of reaction is nothing but this is, in terms of reactant, it's minus, coefficient is 1 by 2, so it will be d of H2O2 by dt is equals to, this is the, you can say here, this is positive of 1 by 2 d of H2O by dt. This is going to be positive of dO2 by dt. Okay, understood everybody? So that is going to be your answer here, that this is rate is minus 1 by 2 d of H2 by dt. This is in terms of product, so it will be positive. All of them are divided by the coefficients. Now, if you see this here, this thing is actually your rate of, and this is your rate of appearance of O2. This is rate of appearance of H2O, and this particular negative and this is actually rate of disappearance of H2O. So now we will do one more thing here, right? That is, let's say you have this thing. Right now, what we will do here? They are asking you, they have given you rate of appearance as 48, right? I'll also tell you a general, one general thing that you can use for any formula, right? Any reaction is given to you, any formula is given to you, you can generally use that, okay? I'll tell you that. Firstly, solve it by traditional method, okay? Then I'll give you a trick here, right? Firstly, you should know, see, if you want to do the questions through tricks, you should also know the traditional method, only then you can apply the tricks. If I directly give you, this is the trick, solve this. In the exam, if they give you something like twist, they give you in the exam some twisted question is given to you, you will be like, I only know the trick, I don't know the traditional method. So you'll be blank in the exam, right? So tricks are beneficial only if you know the full-fledged method, right? So see this. We know that if I want to make a relation between rate of appearance of H2 and this, so answer will be rate of appearance of H2O is going to be, this is 2 multiplied by d of O2 by dt, right? If I want to say, I want to make a relation between rate of disappearance of H2O2, that is going to be, this 2 will shift here, so it will be 2 multiplied by d of O2 by dt. So they were asking you the same thing here, isn't it? As a rate of formation of H2O, disappearance of this, so you're just going to write 2 into 48, here also it is 2 into 48. Answer will be in gram per minute only. Answer will be in gram per minute only. Okay, understood everybody, right? Now, one simple trick if you want to do here, right? That one trick, okay, that is, always remember, we know that rate of reaction is equals to 1 by coefficient, and this is rate of appearance or disappearance, right? So if they simply tell me that rate of the reaction, it is R, let's say I want to apply this trick here. So we know that rate of the reaction will be equals to 1 by 2 of appearance of H2O2 and disappearance of H2O2. This is 1 by 2 disappearance of this is appearance of H2O. This is simply 1 by 1. This is nothing but appearance of O2, right? So you can simply do this thing here. Just always remember that you will always write it directly. Also, you can write, you don't need to write this minus dH2 by this again and again. You can just simply write that In a better way, you can write it like this. In a better way, you can write it like this. Rate of reaction is equals to, this is 1 divided by coefficient of that reactant or product, whatever you are talking about, but only that particular reactant. This is rate of appearance or disappearance of, if it is the reactant, it should be nini. Or if it is appearance, it should be product. Product is getting appeared. If it is disappearance, it should be reactant. Okay. In case of appearance, right, you don't have to put positive, negative here again and again, right? Usually students get confused in positive, negative. So we know that if it is rate of appearance of product, it will be positive here. If it is disappearance, it will be negative here, right? So if you put it, let's say appearance of the product, it should be positive of dB by dt. If say it is disappearance, it will be minus dA by dt. But that is in the appearance and disappearance only. So you don't need to write it again and again. You can just simply write this thing and that will make it easy for you to do the questions, okay? Right? Okay. So you could have just written here, that this is the question that is given to you. Now we know that rate whenever coefficient is 1. One more thing, remember that whenever coefficient is equals to unity, whenever coefficient is unity, rate is equals to that particular rate is equals to the appearance or disappearance of that reactant or product. Whenever coefficient is unity, okay? So we know that coefficient is unity, that means the appearance of O2 is nothing but it is rate only. So now you can easily tell the answer here. You don't need to again and again do this, right? Okay, everybody, right? We will apply now this in the questions, right? So let's do some more questions with this one. Next is your AI PMT question, previous year question only. That is the rate of reaction is given to you, can be written in 3 ways. This and this. This first, this is second, this is third. The relationship between K dash, between K and K double dash, you have to find it out. Now, see this one thing here. If I want to find out the relationship here, what I'll do, right? Firstly, I need to write the full-fledged rate. See, whenever these kind of questions are given to you, write down the rate. We know that rate is equals to, if you see this, in terms of this is 2, this is 4, this is 1. So it will be reactant, it is 1 by 2. This is product, this is 1 by 4. In terms of product, it is 1, right? So this is N2O5, this is N2O, this is O2. So this will be D of N2O5 by dt. This is D of N2O by dt. This is D of O2 by dt. Okay, this is what you have written here. NO2, na? This will be NO2. If it is given to be NO2, then it will be NO2. Okay, so now this thing you have already written. Okay, now rate you have written in terms. Now I think now though you are pro in this, is it? Now are you finding it difficult to write down your rate of reactions here? Right? Ma'am, a request, please solve where the question is there. Okay, there was less space, no? That's why I solved it here. Right? I thought you will be thinking that, ma'am, why are you solving this on the question page only? Right? So I'll take care of that in the next question. Right? And what I'll do now, I'll try to keep the question like in a less area of the screen so that I can solve the answer on the same page. I think that would be more better for you guys, right? So now you have, this is your rate, right? Rate is done now. Now, if you see this here, now this is minus dN2, minus of this means disappearance is given to be K of N2O5. So can I write this here? This is given to be, this R is equals to, this is given to be K into N2O5. So I'll write K here. So it will be K by 2 N2O5. I just have to substitute the values here. This thing is given to you as K dash N2O5. So can I just write here K dash N2O5? Next is this thing is given to you as K double dash N2O5, right? So can I write it here? K double dash N2O5. K double dash N2O5. Okay. So can I just write it here? Simple. Now, if you need to find the relation here, right, easily you can do that. How? They are asking you find a relation between K and K dash. So just find it here. This N2, this is N2O5, this is K dash, this is also N2O5. Cancel this, it will be K is equals to 2 of K dash. That is your first relation. Okay. Second one is you have between K and K double dash. This is K double dash. So it will be K by 2 N2O5 is equals to K double dash N2O5. This will cancel. This will be again K is equals to 2 into K. Array, we forgot to write here 4. Where is this 4? Now it will be different. This is K by 2. This was K by 4. This was K by 4. I forgot to write here 4. My bad. I forgot to write here 4. This should be 4, right? So this will be 1 by 4. So it will be K is equals to, this will cancel out. It will be K dash by 2. K is equals to K dash by 2. And here it will be K by 2 N2O5, K dash N2O5. So it will be K is equals to 2 into K double dash. Okay. Clear everybody? Yes. Yes. My bad. Right? That is true. Right? So here it will be K dash by 4 because this value they have given you. I forgot to write 4 there. Right? See how one silly mistake can change the entire answer and you end up losing your 4 marks that you were about to gain and you end up losing 1 because of that one negative marking, total 5 marks, right? Because of one silly mistake, right? Can you see? That's why practice is more beneficial. For me, though, I don't have to write the exam, but for you have to sit under that a lot of pressure in the exam. You are vulnerable enough to do like silly mistake in the exam hall. That's why I tell that please solve as many questions as possible. Okay. So next is for the reaction, this reaction is given to you. The value of rate of disappearance of N2O5 is given. Okay. So that means disappearance of N2O5 is given. Now can we write the disappearance of N2O5? Disappearance means minus. This is dN2O5. This is by dt. This is given to you 6.25 multiplied by 10 raised to power minus 3 here. Right? Now if you see, is given to you the rate of formation of N2O and O2 is given respectively as. Okay. So write down the rate of the reaction. So what is the rate of the reaction, everybody? What is the rate of reaction? Rate of reaction is minus 1 by, this is stoichiometry is 1, so it will be minus dN2O5 by dt is equals to, see, can I just write, see when the coefficient is 1, can I say the appearance or the rate of disappearance is going to be same? I am telling you this with the help of shortcut, right? So if here the coefficient is 1, can I say this is nothing but this is also rate of reaction? This is also rate of reaction as coefficient is 1. So can I say that this is also the rate of, see if you are not able to understand this shortcut method, then you can do by long method, right? If you're able to understand, that will be great, right? So rate of reaction is when the coefficient of some reactant or product is 1, then rate of reaction is equals to rate of disappearance or appearance of that particular reactant or product. So that means I can say that rate of reaction is this only. Now when I know rate of reaction, now things are very easy. Now for N2O, if I want to write rate of appearance of NO2, that will be this 2 multiplied by rate of reaction, that is 6.25 multiplied by 10 raised to minus 3. Rate of appearance of O2 will be coefficient multiplied by 6.025, 6.25 10 raised to minus 3. You can directly write it. You don't need to get into that, right? Okay. How many of you are able to understand this shortcut method? Viranki is saying, ma'am, yes, I am able to understand. That's great. How many other students are able to understand? This I got from this thing only, no? Rate of disappearance or appearance of any product or reactant is equals to coefficient of that product or reactant multiplied by rate of reaction, right? So you can just directly solve this, okay? Yes, everybody? Clear? Shall we move with the next question here? That is, I think this is the last question from this, but no, not the last, but the second last question here. Because after that, we are going to move with the next topic, right? That is rate law expression. So for a chemical reaction, this chemical reaction is given to you. Rate of formation of C is given to you. C is given to you. Now, can you tell me what if rate of formation of C is given? What is the rate of reaction? Rate of reaction will be coefficient. Rate of reaction will be which thing? This will be rate of appearance or disappearance. This is formation. So it will be 6 into 10 raised to minus 2 divided by coefficient. This is what I told you here. No, this is what I told you here. Rate of reaction is 1 by coefficient of rate of appearance or disappearance, right? So now I am going to solve it with the shortcut method. Why shortcut? Because 180 minutes, 180 questions, right? So shortcut you have to apply, right? Long method you should know, but shortcut you should apply if you really want to save your time in the exam. Otherwise, you will end up solving one question only, right? That we should not do, right? At this point, you still have time to learn these methods, right? So rate of reaction is this rate of appearance, disappearance divided by coefficient of C is 6, so it is 1 by 6, right? Now, they are asking you rate of disappearance of A is this. That means you can say, okay, rate of reaction and amount of B consumed in the interval of 10 seconds. Now, so we have rate of reaction. Rate of reaction can also be this. Rate of reaction can also be calculated as disappearance of A, that is 4 into 10 raised to minus 2 divided by its for disappearance of A. What is the coefficient of A? That is 4. Can you see you are getting the same answer? That is 10 raised to minus 2. Can you see you are getting the same answer? Now is that verified? Right? Same answer you're getting, you solve it from this or this. Rate of reaction and amount. Now can you see by using this shortcut method, one thing is I am able to apply 2 methods to solve this. Other thing is I have found it out in just seconds, right? Next is amount of B consumed in interval of 10 seconds. See B, how much B is consumed, you have to tell. So that is B disappearance. So what is disappearance of B? Rate of disappearance of B. Rate of disappearance of B is coefficient of B, that is 3 multiplied by rate of reaction. Can I say coefficient? Whenever you are calculating disappearance, appearance, that is coefficient is multiplied. Whenever you are calculating rate of reaction, coefficient is divided. So this will be 3 multiplied by the rate of reaction. Okay. Now, simply what you have to do is, ma'am, they are asking in 10 seconds. So we know that rate is calculated in per second. Rate means I am calculating here per second. That means this is about per second. So if I want to calculate, so in 10 seconds, it will be 3 into 10 raised to minus 2 multiplied by 10. That is 3 into 10 raised to minus 1. Is that the correct answer? Right? Is that the correct answer, everybody? Easy, easy peasy. Now, this question that I'm sure that you would have written firstly rate of reaction, then rate of appearance, then rate of disappearance, then ma'am how to calculate it in 10 seconds, it would have costed you a lot of time, right? Now easily rate of reaction is coefficient multiplied by that appearance. So here I am talking about C. So it is C multiplied by coefficient is 6. So answer will be 10 raised to power minus 2. Appearance is coefficient multiplied by the rate of reaction. Coefficient is 3, right? 3 multiplied by rate of reaction. For 10 seconds multiplied with 10 seconds, right? Simple. Okay. In 10 seconds, it will be beta 10 is 3 to 10 is per minus 1. Okay. Minus 2 and 1, this is going to be minus 1. Right, that I told you in like your mathematics class of chemistry, simple mathematics used in chemistry, right? Now for a lecture, for a reaction, that is this, the average rate of appearance. Now for this particular reaction, the average rate of appearance of B is given by delta B by delta T. For appearance, it is given by this. The correct relation between average rate of appearance of B with average rate of disappearance. What's the big deal in this? Disappearance is minus delta A by delta T. Appearance is positive of 1 by 2 of delta B by delta T. And that is going to be your relation, right? This you can say here, you can write it like this. The average rate of disappearance of A, this is disappearance of A. So you can write rate of disappearance of A is equals to 1 by 2 of rate of, because this is your appearance, right? Rate of appearance of B, right? Easily you can find it out, right? Okay, students, right, everybody? Okay, everybody. Now, are you feeling confident on this? Can you explain the right part here? Arey, rate is always in per second. If for 1 second it is this, then for 10 second it will be multiplied by 10. Na? So that's why I multiplied it by 10. Okay. Now, let's see this one. Now, let's understand the factors affecting concentration. Now, factors affecting rate of reaction. So, one factor that we are going to learn is concentration. How concentration affects the rate of a reaction. For that, we will study rate law equation, right? Now, what is rate law equation, right? So, rate law equation, to understand that, what we need to understand is for a rate law equation, rate is equals to rate constant multiplied by, let's say you have a reaction that is A, B, B, give rise to C, C plus DD. Now rate of reaction is equals to rate constant, concentration of the reactants raised to power the stoichiometry, raised to power any power, right? Now this power that is there, it can be coefficients, it cannot be coefficient. And this particular thing is called rate law equation, right? So what is there? Rate law is the expression in which rate reaction is given in terms of molar concentration. This is the molar concentration. That means expressed concentration is expressed in terms of molarity. Here always, you can't put here pressure or anything. Always it is in terms of molarity, right? Reactants with each term raised to power some power. They have not specified what is that power. That X or Y may or may not be coefficients. They may be coefficients, they may not be coefficients. We are not sure about it. Okay, we are not sure about it. Okay, which last question? Wait a minute. Array, nothing here. Instead of small d, we have written capital D. Achha, here we have not. I think, okay. This should be coefficient was 3 also. I forgot to write 3. I have not seen only 3 here. I think because of light reflection, I was not able to see that 3 there. So it will be 3 now, so it should be 3 by 2. Right, right, right. It should be 3 by 2. I think now it is clear, right? That was the problem. That was the problem. Now clear? Okay, everybody, I think now it's clear. The last question, right? Okay. In the last question, it is the reactant in terms of reactant is minus delta A by delta T. Coefficient is 1 by 3. This is plus 1 by 2. Coefficient is 1 by 2. Delta B by delta T. This is the rate of appearance of B. This is rate of disappearance. This particular part is disappearance. So that's why it is rate of disappearance of A is equals to 3 by 2 rate of appearance of B. Right? Okay. Yes, everybody. Everyone. Now, let me know if that was clear. Right? Great. Now, this is your rate law expression. And I told you that in rate law expression, what we do is rate is equals to rate constant multiplication with molar concentration raised to power some power. Now this power x and y may or may not be the coefficients in that reaction, right? So which may or may not be same as the stoichiometry coefficient of the reacting species. Now ma'am, why may or may not? Ma'am, when this can happen, ma'am, when this cannot happen, let's talk about that. So for that, you need to understand firstly that there are two types of reactions that we are going to study. First type, second type. First type is the elementary reaction. Elementary reaction. And second type is the complex reactions. Okay, second type is the complex reactions. So if I talk about elementary reaction, that is a single step reaction. That's a single step reaction. One step reaction. Complex reactions are multiple step. Multiple step. Firstly, A will be converted to some intermediate C, then the C will be converted to B. That's how A is getting converted to B. That is a multi-step reaction. Okay, so whenever I talk about an elementary reaction, that is a single step reaction, in this case, power is equals to stoichiometry. Stoichiometry coefficient. Stoichiometry coefficient. But in case of complex reactions, power is not equals to stoichiometry coefficients. Stoichiometry coefficients. Okay? Is that clear, everybody? Is that clear, everyone here? You have two things, right? Again, I am just concluding that here. That if you have, let's say, elementary and complex reactions, I have, this is, reaction is, you can say the reaction is AA plus BB give rise to CC plus DD. If I say this reaction is a elementary reaction, if in the question they have given it's a elementary reaction, or if they have given it's a complex reaction. If they have given it's an elementary reaction, then I'll simply write rate is equals to rate constant. This is A, this is B, raised to power the stoichiometry only, right? But if they say it's a complex reaction, then rate is equals to K, A, this is B, raised to power the power which is not the stoichiometry coefficients. Everybody in the chat box, let me know if that is clear to everyone or not. Let me know in the chat box if that thing is clear to you or not, that in an elementary reaction what happens, in a complex reaction what happens, right? Okay, everybody. Everyone, please don't chit chat in the chat box, right? So focus on the studies. Let's not talk about this and that. Full focus should be there, right? People will try to distract you, but you don't get distracted, because the loss you are having is your seat, and everyone is competing out there for that, right? For me, nothing is going. For you, everything will go, right? So please don't waste your time and don't, if you're in the class, focus in the class. If someone is genuinely asking you some question, answer that. If you see that someone is just doing time pass, ignore that person, right? Okay, very good. Hello, Ria. Hello, welcome to the class. Welcome to the class, Ria. Okay, so that was it. Now, this x and y, right, that we are talking about here, this x and y that we are talking about here, right, that is actually forming the order of the reaction. That is x plus y. So a new term after rate law expression is order of a reaction. It is the sum of power of concentration of reactants in the rate law expression. In the rate law expression, the powers that you have here, right? You can see that these are the powers that you have, right? In this case, the order of the reaction is A plus B. In this case, the order of the reaction is X plus Y. So whatever is the rate law expression, in the powers of the reactant, the values, when you add all those values, you get the order of the reaction. Order with respect to A is A here. Order with respect to B is small b here. Order with respect to A here is small x. Order with respect to B here is small y. Full order of this reaction is x plus y. That is called the order of the reaction. And based on order of the reaction, we have so many questions that we are going to talk about in the next lecture, right? So, order can be any integer. It can be in fraction, it can be negative, it can be positive, it can be zero. Order can have any value, fraction, positive, negative, zero, that is there. And order is an experimentally it is derived. Okay. So now tell me one thing. Who will tell you this is an elementary reaction or a complex reaction? Experimental data. Now, if that experimental data says that it's a complex reaction, then order of the reaction is not dependent on the overall reaction. It is dependent on the slowest step. It is dependent on the slowest step, that is the rate determining step. That is the rate determining step. So rate determining step is your slowest step, and that slowest step will tell you the rate of the reaction. And how you will get to know the rate determining step? Rate determining step will be defined experimentally. That's why order of the reaction is also experimentally derived, right? So you can say example is this. From this example, you can say, ma'am, easy ma'am. Rate is equals to, ma'am, K N2O raised to power 2, ma'am. This is the stoichiometry, right? But if I say this is a complex reaction, that is, I am telling you experimentally that I have done experiment, this is turning out to be a complex reaction. So, in complex reaction, this cannot be the rate, right? So that means that we will define experimentally that the order is coming out to be 1. That means in reality, it is N2O raised to power 1. That we have defined experimentally. So order of the reaction is an experimentally derived quantity. Okay. Now, next is from the order of the reaction, I am talking about, see, one is we are talking about this rate. Okay. One is we are talking about this rate. Other is rate constant. Now, who will tell me what were the units of rate? Who will define the units of rate here? Let's see who will define the units of rate here. Let's see that. Let's see that. Wait a minute. I'll just ask Baswa sir to start the class at around 8:20. Okay. Yes, everyone. Now tell me one thing. If you, what was the rate of the, what was the unit of rate of reaction? So what is thing, right? We know that it is rate equals to rate constant. This is concentration raised to power order. Order I am writing by small n, right? Now, they are asking that in terms of order, you tell us what is the unit of this rate constant. That means we know that, can I define it like this? We know that rate constant is equals to rate divided by concentration raised to power n. Now you need to tell me what is the unit of rate. Everybody, I can't see even one person who is writing here. What is the unit of rate? What is the speed flow? Yes, that is the definition. What is the unit of rate? Unit of rate, I have told you, mole per liter per second. That is the unit of rate. If concentration is in molarity and your time is in seconds, right? And we know that concentration is mole per liter, right? So can I write that rate constant will be mole per liter per second divided by mole per liter. This is raised to power n because concentration is raised to power n. So can I write it here that rate constant unit is mole per liter. This is 1 minus n because this is raised to power 1, this is raised to power n. So it will be 1 minus n per second. And this is what I have written here. They are the general units of rate constant that you can say in terms of order of reaction. Okay, general units of rate constant in terms of order of reaction. Now order of reaction is 0, you will put n is equals to 0. Order of reaction is 1, you will put n is equals to 1. Order of reaction is 2, you will put n is equals to 2. According to that, you can generate units of rate constant for any of the following. Right? Okay, everybody. I can see you guys are getting distracted now. What's the problem? Why you guys are getting distracted? Right? There is some girl in the chat box, ma'am. I want to talk to her. Right? I want to spoil my career for that girl, ma'am. I don't care about your rate and rate constant. I don't care about that. Please let me focus, ma'am. Let me destroy my career, ma'am, for once. Right? Do you want to do that? Right? Why are you getting distracted here? Don't get distracted, right? Please. People will spam here. People will time pass here. Even students who are genuine, even they don't know that they are doing time pass. For them, they are doing fun, right? But in reality, they don't know they are actually destroying their career and someone else's career also, right? So let's not get distracted. Your focus, your concentration should be there, right? If your concentration is there, then only you will be able to understand this concentration. Otherwise, it will go over your head and in the end, you will be like, chemistry is difficult. Chemistry is not difficult. You need patience, you need regular consistency. That's it. And everything you can leave it on me. Right? Okay? Yes. Now, let's talk about, that in that particular formula, right? Just put down the value here. In this particular formula, you just have to put the value here. I'll just, instead of writing it this way, you write it this way, right? Write it this way. Mole per liter 1 minus n per second, right? You put n is equals to 0, it will be mole per liter per second. You put n is equals to 1, 1 minus 1 is nothing but 0. Anything raised to power 0 is 1, right? So answer is going to be per second, right? This whole value will come out to be 1 because 1 minus 1 is 0 and anything raised to power 0 is 1, right? Anything raised to power 0 is 1. Okay. Next is you put it 2 here. 1 minus 2 is minus 1. So it will be mole. It will be per mole liter per second because it will become mole per liter minus 1 per second. So it will be per mole liter per second. So that will be the answer for second order reaction. Clear, everybody? Now, let's understand how to determine, right? Let's focus on one question, then we will understand how to determine the order of the reaction. There will be, I'll not explain theory part of how to determine order of the reaction. There is no theory part of it. I'll just give you the questions. We will solve the questions, then we will understand how to determine it. I'll give you different set of questions that they give you in the exam. Okay? Yes, everyone, let's see this. Now it is there that if concentration of the reactant of an elementary, first thing is elementary reaction. Elementary reaction, now tell me, can I say power is equals to stoichiometry? Can I write it? Is it a correct way of writing R is equals to K, reactant is A, reactant is B, stoichiometry is 1, stoichiometry is 2. Can I write it this way? Is it the correct way of writing the rate law? Is it the correct way for an elementary reaction? Now, they are saying that is increased, concentration of reactant of this is increased 3 folds. Concentration of reactant, that means A is also increased 3 times, B is also increased 3 times. Both are increased 3 times. Students, both are increased 3 times, okay? So that means in the new rate, very good. In the new rate, it is 3A and this is 3 of B square. So it will become K3, or you can also write 3 here. This is 3 square. It will become 3 cube. This is K, this is A, this is B square. So it will be old rate. This is 3 into 3, 9. 9 8 27. That means 27. So new rate will be how many times of old rate? That is 27 times. So A is going to be the correct answer here. Very good. Already you have written it there. Excellent. Right? Now, let's understand how to determine order of the reaction. Okay? Ready for how to determine order of the reaction, everybody? Let's see how to determine order of the reaction. Ready, everybody? How to determine order of the reaction. Yes, everyone? Let's do this. If I talk about order of the reaction, right, they will give you so many different ways. Okay, one way is I'll give you simple trick, right? I have not copy pasted it from any book or anywhere, right? Just by solving, I got this idea that we can also solve it like this. Okay, and that, trust me, that is a very interesting idea for you. So one way, I'll just write here how they ask you the question. They will say concentration is doubled, or sometimes they will say concentration is tripled. Sometimes they will say it is increased 4 times. Then they will say then rate is doubled, then rate is tripled, or rate is 4 times, rate is 8 times, rate is 16 times, something like this. Okay, so two things they will give you. One is how many times concentration is doubling, or it is 2 times, it is 3 times, it is 4 times, it is 5, 6, 7, 8, 9, 10, whatever times. Okay, so one thing is they will give you how many times the concentration is increasing. So concentration change or concentration, I will express it in X. In the formula that we are going to write down here, that is in terms I am expressing, if they are saying it is getting doubled, so X is equals to 2. If it is getting tripled, it is 3. If it is increasing 4 times, so it is 4. If it is increasing 6 times, it is 6. It is increasing 5 times, it is 5. Okay, usually they don't give 5 times, but still, right, whatever is given to you, right? Now, how many times the rate is increased, right? How many times the rate is increased? First thing is order of the reaction in the formula will be N. Okay. Now see this. I am writing that R nu is equals to X raised to power N times of R. Just remember this. This will simplify your questions to a next level, right? R nu is equals to X time R old, right? Now, can I say the amount of time the rate is changing, it is X raised to power N. From this formula, can I say it is X raised to power N? Firstly, tell me how to apply this formula. That I'll tell you with the help of question. You just tell me this thing. Are you able to understand from the question how you will understand what is the value of x? How you will understand what is the value of x raised to power n? Is that clear? You know, in the questions, they will ask you concentration is increased this much time, rate is increased this much time. Tell us what is the order of the reaction. Give us the formula of rate law expression, right? This is what they ask you. Right, everybody? Okay. Now, I'll just solve these questions in front of you, what exactly we are going to do here, right? So this is the question of your previous year question only. For a reaction A plus B to product, it is observed that A plus B, that means rate law will be R is equals to K, A or B. Something X or Y will be there. Some power will be there. I have no idea. I'm not even going to write it X or Y. Here I'll write it N. Here I'll write it M. With respect to A, I am writing the order of the reaction is N. With respect to B, the order of the reaction is M. Okay. Now, I want to know what is the answer, and it will take you hardly few seconds, right? So first is on doubling the initial. In the first part, now I am writing with respect to A. I am calculating the value of N, that is order of reaction with respect to A. On doubling initial concentration of A only A we are doubling, the concentration of the rate of the reaction is also doubled. That means, can I say they are saying initial concentration is doubling. That means x is equals to 2. Rate is also doubled, means x raised to power n is equals to 2. Now, can you tell me what is the answer? Right? X raised to power n is 2 means, see, x is equals to 2, x raised to power n is equals to 2. Can I just simply write here x is 2 means 2 raised to power n is equals to 2. It means n has to be 1. In just seconds, you have answered this, right? That is the benefit of that formula. In just seconds, you will be able to answer that this is nothing but n has to be with respect to A. Order of the reaction has to be 1. Only then 2 raised to power n is equals to 2. Those who are not able to understand this, see this thing. With respect to B, okay? With respect to B, order of the reaction is m, okay? Now here you will see on doubling the initial concentration of both A and B. Now you are doubling the concentration for both A and B. There is a change of by the factor of 8 in the reaction. Okay. So if I put here R is equals to K, A and this is B raised to power M. If I double this concentration, this will be doubled. If I double this concentration, if this M is equals to 1, if I say M is equals to 1, then it should be 4 times. This means this M is equals to 2, only then this is becoming 8 times, right? This M should be equals to 2 only. You put M is equals to 1, you will see it is not becoming 8 times. If you put M is equals to 2, only then rate of reaction is becoming K into 2A. This is 2B square. That is 8 times of cold rate. This is only possible. So we can say N is equals to 1 and M is equals to 2. That is the correct answer here. Clear, everybody? Okay. Thank you, Zoro. Thank you. Thank you, Kasi Rajan. Thank you. So is that clear, everybody? That is clear now. Is there any problem in this question? Because this is a very, very important thing, right? We are also going to this. Okay, great. Now, let's see another way of asking the question here, right? There is one more way of asking this kind of question, that is in the tabular form. In the table form also you will see the questions, right? So how they ask you questions in the table form, let's see that, okay? Yes, everyone, let's see that how they ask you the questions in table form, right? So in table form, the following results have been obtained during kinetic studies of the reaction. This is given to you. Now, I'll just take R is equals to K. A raised, see, they have not given its elementary, its complex, so I'll take A and B. This I'm taking with respect to A, it's N, with respect to B, it's M. This is what I'm taking here, right? Now, students, see this thing here, that in the table form, you will see, okay, wait a minute. Okay, so in the table form, what you will see that usually it is solved with the help of rate law expression, making multiple equations, but we will not solve it like that. Remember, 180 minutes, 180 questions. Is it possible? Right? If you start making equations and solving, it's not possible, right? So let's be real here. Let's see that how to get marks here with these kind of questions, right? So what we will do, we will fix concentration of A firstly, then concentration of B. Can you see any part where concentration of A is constant? See, if you see that, ma'am, it is not constant, let's say nowhere it is constant, then you have to make it constant. Then you will divide this by 4, you will divide this by 4, right? That's how you will make this constant, right? So, but you know that they will not give you, but don't worry about that, right? So, let's see, this is constant here. No, this is constant here, 0.3, 0.3, right? So, if this is constant here, now I will solve this with respect to A, right? First thing is I'll solve this with respect to A. So I'll just write here with the respect to A, it is, with respect to A it is, if this is constant, can I say that it is getting double? So I'll just copy paste this. So now I'm just writing here, making A constant, making A constant, A constant. So you have to make one concentration constant. This is getting doubled, right? That means, can I say, with respect to B, I am calculating with respect to B. With respect to B, if A is constant, B is getting doubled. So can I say that X is equals to 2? X is equals to 2 from that formula, right? And how much amount this is increasing? 7, 7, what is 7, 21, 7, 4, 28, right? It is 4, right? So this will be 4 times, right? 7, 4, 28, right? So it will be 4 times. So can I say X raised to power N is 4? Rate is increasing 4. See, I told you this trick. I told you that, I'll just write it here. I told you that new rate is equals to X raised to power N of old rate. From this value, I am writing it here, right? So concentration is increasing double, rate is getting 4 times. So can I just write it here? 2 raised to power N is equals to 4. That means N should be equals to 2, right? So that means, and with respect to B, it is M now. So I should write here M. Okay, I should write here M. This should be M. Why? Why this should be M? Because order of the reaction is, I have taken with respect to B, I have taken it as M. So I'll write it as M. Okay. So can I say that the order of the reaction will be 2 raised to power M is equals to 4. That is, M should be equals to 2. If M is 2, only then it is possible. Otherwise, it's not possible. Right? Okay. Next. Now, I'll have this thing. Now what I'll do, right? I'll solve it with respect to A. So for that, I have to fix the concentration of B. If this I have to fix, I'll fix it here and here it is fixed, right? Now I can write that fixing concentration of B, right? If I fix the concentration of B, corresponding to B, you have A, this is A, right? Corresponding to B. Can you see this is into 4 times? So can I just say this is multiplied by 4, right? And what about this one? This is also, well, how many times? Everybody in the chat box. Everybody in the chat box. How many times this is increasing, decreasing, increasing, no? How many times it is increasing? Can I see this? For NEET aspirants, ma'am, this is the biggest thing that, ma'am, we have to calculate, right? How many times? This is 4 times, no? Can you see? It is increasing 4 times, right? So now here, rate is equals to, or you can say new rate is equals to x raised to power n times old rate, x raised to power n times old rate, right? So how many times concentration is increasing? That is 4. So I can say that x is equals to 4. X raised to power n is how many times rate is increasing? That is also 4. That means 4 raised to power, that means 4 raised to power n is equals to 4. That is only possible if order is 1, that is if n is equals to 1. So can I say that, can I write this as R is equals to K, this A is 1 and this for B it is coming out to be 2, and this will be your final answer, right? This will be your final answer here, right everybody? Okay. Right, very good. You have also calculated the rate constant. Now to calculate the rate constant, what you have to do, we know that rate is coming out to be this. We know that we have calculated the value is R is equals to K, A, this is B square. Now K is nothing but this is R divided by A and this B square. You take out any value, any value. Let's take the first value where A initial concentration is 0.1. So it will be 0.1, this will be 0.1 square. And here rate is coming out to be 6 into 10 raised per minus 3. This is 6 into 10 raised per minus 3. You can take anything. You can choose this one, you can choose this one, you can choose this one, anything. But to make calculations easy, we have chose the first one. So rate is going to be, you solve it. This is going to be 6 into 10 raised per minus 3. This is also 10 raised per minus 3. You cancel it. The rate will be 6. Right? Okay. Now tell me, this is a third order reaction. What is going to be the units? Guys, this is a third order reaction. Third order reaction, what was the value of units? Everybody, what was rate constant? We know that rate constant is equals to mole per liter 1 minus n per second. Order is 3. Overall order of the reaction is 3. So it is 1 minus 3. It will be mole per liter minus 2 per second. That will be the units. So you can write mole per liter minus 2. This is minus 2. This is per second. Right? But one thing should be there. It should be in liter if nothing is given. So I'll take this as the units. Okay? Everybody clear? Now, another kind of question is from the tabular form. They have given you a table here. They are saying rate is this much, A is this, B is this. No idea. They are saying the order is 1 with respect to A and B. Simple. R is equals to K. Order is 1 with respect to A. With respect to B also it is 1. Right? Now they are saying you have to calculate the value of this X here and this Y here. How do you calculate it? How do you calculate this value, guys? Simple. Right? Okay. Now, see this here. Talking about the next statement here, we know that they are saying that rate is getting 0.4 times this K and this is the X, right? And this is 0.5. Now, instead of solving it, see, usually what students do from this, firstly, what I'll tell you what is the traditional method. Right, that is a very lengthy method. You should know that, but I would not advise you to do it in the exam. Firstly, you should put the value of A and B here, then rate here, then solve the value of rate constant. Then you will put in the second experiment, you will put the value of rate, you will put the value of A as X, you will put the value of B as 0.5, then you will calculate the value of X. Then you will same way, you will calculate the value of Y here. But that I will never advise you, right? Okay, so what you should do here, let's see. Simple thing is, see here it is 4 times, right? This is constant. This is not increasing. So how many times it should increase? Simple thing is, if this is constant, this is increasing 4 times, then this has to increase 4 times. If at least one of them should make some progress, right? If the overall rate is increasing 4 times, this is not increasing. That means this is increasing 4 times. So can I say if this is 20, the next is going to be 4 into 20, that is 80 is going to be the value of x here, right? Similarly, you will do the same thing here, that is r is equals to k, this is a, this is b, right? Now if you see this here, in this case, I have no idea how many times b is increasing, but one thing is for sure, that rate is increasing 8 times. So this they are saying is increasing 8 times, okay? This is increasing 8 times. A is increasing. This is coming out to be 80 here. So now this is not increasing. This is decrease. Now, if you, from the original value, yes. From here it is increasing how many times? 2 times. 20 to 40 it is multiplied by 2, right? So it is increasing 2 times, right? That means A is increasing 2 times. This is 1, this is 1. This has to increase 4 times, okay? If this is increasing 4 times, then 4 multiplied by 2 will be 8. That means this has to increase 4 times. That means this is going to be 0.5. So you can say y is equals to 0.5 into 4. That is 2, right? And x, you can solve it like this. X is equals to 20 into 4. That is 8. Right? That's how you will answer x and y here. Clear, everybody? Okay. Yes, 80 and this is point. It's not 0.4 times, simply 4 times. Okay, that you can say. Right, everybody? Any problem in this particular concept? If you have any problem in this particular concept, then you can let me know in the chat box. Right? No. Y will be 2. Okay? 0.5 into 4 times. This is increasing 4 times. See, this is increasing 8 times. This is increasing 2 times. For this to increase 4 times, this has to increase 4. For this to increase 8 times, this has to increase 4 times. So this is 4 into 2 is 8, no? So that means this will be increased 4 times. Okay? Yes, crystal clear? Perfect. Now, answer will be 80 and 2. A will be the correct answer. Right? Okay? Yes. Now, let's see. Next is your last kind of question that we are going to do here. And one of the most important questions, right, for your exam point of view, right? I would say it is one of the biology class. I had texted sir, right? Just see. Wait a minute. Guys, it will take me time to cover it up, right? So let me just cover this, right? Okay. Part 2 will be there. Yes, there will be order of reaction. There will be first order, second order, third order reactions. Everything will be there, right? So let's do the last kind of question, right? This is the last kind of question. 2 more questions and one definition of molarity. That's it, right? That's it. Molecularity, right? That's it we have. Now let's see this here, everybody. Order of the complex reaction. Now this is the set of question that is given to you. They will give you the order, they will give you this complex reaction and they will ask you that this is the mechanism of the reaction and they will ask you to give the order of the reaction. Okay, this you have to do here. So let's see this. Okay, so let's see this. So students, what we are going to do for this, everybody, I have 2 questions based on this. So one by one we are going to solve this. Firstly, always remember the order of the reaction depends on the slowest step. And this is the slowest step that you have. So we can say that The order of the reaction depends on the slowest step. So rate of reaction will be K into A and B2. A raised to power 1 is the stoichiometry and B2 raised to power 1 is the stoichiometry. So answer is going to be A and here it will be B2. Mark it 1 here. Firstly, whenever this set of question is given to you, you will see the slowest step. You will write your answer in terms of the slowest step here, right? You have written it here. Now, next is, and remember this K2 is actually not here. This K2 is not for this one. This K2 is for this one. Okay, this K2 is for this equilibrium, right? Now, always remember that whenever you are writing the order of the reaction, never ever write in the overall reaction, B2 is there, A2 is there. In the overall reaction, can you see A? No. So in the order of the reaction, in the rate law expression, you never write intermediate. So that means A is the intermediate here. So we have to replace A. To replace A, we will see an equation which is actually giving you equilibrium, right? That is this equation. So this equation is giving you the equilibrium. So what we will write, equilibrium constant, that is equals to, I'll write it as Kc also. You can write it in terms of this also. You can write it in two ways. You can write it that K1 multiplied by the reactant side, A2, K2 multiplied by its reactant side. So for the backward reactant, this is the reactants. That is A square. For a forward reaction, this is the reactant, that is A2. For a backward reaction, this is the reactant, that is A square. A into A, that is A square. Now I know that I have to replace or substitute A as it is intermediate. Intermediate you have to replace here, right? So that means find out the value of A here. A will be equals to, you can find it like this. A will be equals to K1 by K2 under root and A2 under root, right? This is your second equation. Put 2 in 1 and you will get the final answer. Rate of reaction is equals to K. This A is nothing but it is K1 by K2, 1 by 2. Then this is A2 raised to power 1 by 2. This is B2. Okay. This overall thing, this whole constant, I'll take it as K3. So you can take it as K3 here. This, all the constants, you can say it as K3. So it will be R is equals to K3, A2, 1 by 2 and B2. So can you say the order of the reaction is? Order of the reaction is half plus 1, that is 1.5. Okay, order of the reaction is 3 by 2 or 1 by 5 here. Is that clear to everybody? Right? Is that clear? Now, for those students who are confused in this particular kind of question, I have one more set of questions for you regarding this. Okay, one more question we will do. See, whenever you have a complex reaction, they ask you the order of the reaction. First step is see the slowest step. Which is the slowest step? This is the slowest step. So write down your rate of reaction in terms of slowest step. So rate of reaction will be reactant, that is, first is rate constant multiplied by reactant oxygen, reactant O3, right, raised to power the stoichiometry. Stoichiometry is 1, stoichiometry is 1, right? First step is to write down your rate of reaction in terms of the slowest step, right? Now, second is we have to substitute the intermediate. For that, you have to see which is the intermediate. In the overall reaction, you have O3 and O2. So O3 is there in the overall reaction. That is not the intermediate. But this is the intermediate here. You have to replace oxygen. That is the nascent oxygen. You have to replace it. Because this nascent oxygen is not there in the full-fledged reaction. So that's how you see that which is the intermediate that you have to replace, right? With the one that is not there in the overall reaction, right? So now from this particular thing, I will have that if I mark it, let's say I'm marking this one as K1, this one as K2. So can I say that this is K1? This is constant only. You can yourself also mark it K1, K2. For the backward reaction, I am saying K1. For the backward reaction, it's O2 and this is oxygen, right? Is equals to for the forward reaction, it's K2. For the forward reaction, this is the reactant, so this will be multiplied by O3. Now I have to find this oxygen value here, so oxygen will be, so can I say oxygen is going to be K2 by K1, this is O3 and this division will be O2, right? Very important this is, right? So this value I'll put here, I'll substitute it here, right? Simply R is equals to K, oxygen is nothing but this is K2 by K1, right? This is O3, right, by O2, this is O3. So when you solve it, you take this whole as K3, this is R, this is O3 square, this is O2 raised to power minus 1. That means, can I say order of the reaction with the respect to O3 is 2. With the respect to O2, it's minus 1. That's why I told you order of reaction can be negative. You yourself have seen it. Order of the reaction can be in fraction. Order of the reaction can be 0. Order of the reaction can be negative as well. It's a proof, right? So, overall order will be 2 minus 1, that is 2 minus 1, that is 1. Overall order will be 1. Okay, everybody? Okay, everyone? Is that clear to everybody or not? Here with respect to A, it was, here with respect to, wait a minute, here with respect to A, we solved it with respect to A, it was coming out to be half. With respect to B, it was coming out to be 1. Overall order was coming out to be 1.5. Okay, understood? Will you be able to do these kind of questions or not? Everybody in the chat box, let me know. Will you be able to do? If you will be able to, if you promise me that you will not do any silly mistake in these kind of questions, just spam green hearts in the chat box, spam fires in the chat box if you are confident that you'll be able to do these kind of questions in the exam, right? Because these are very, very important. Now, last topic of today is molecularity. Now, molecularity is number of, now this is a very simple thing, right? So, molecularity is number of species, number of reactants that are colliding to make products, right? So, number of reacting species, atoms, ions, molecules that take part in an elementary reaction. And molecularity is only defined for elementary reaction. The definition of molecularity is not for complex reaction, it's for elementary reaction, right? Which must collide simultaneously, that must collide in order to bring out a chemical reaction, right? We know that how reactions are happening because atoms, reactants collide with each other to make products. So the number of reacting species that collide to make products, that is called the molecularity. Now molecularity cannot be 0, it cannot be negative, it cannot be non-integer, right? See, 0 molecules can't collide with each other. We know that negative, minus, I say minus 1 molecule are colliding, not possible, right? Non-integer, 1 by 2, half molecule is colliding, not possible. Either 1 molecule will collide or 2 molecules or 3, right? So, non-integer is also not molecularity, right? Now, this is defined for an elementary reaction, right? What is the molecularity of the above reaction? That is, molecularity is 2-3 species are colliding. What is the order of the above reaction? For order of the reaction, we know that for an elementary reaction, order will be 2 plus 1, rate will be R is equals to K, A raised to power 2, B raised to power 1. So, order will also be 3, right? So can I say that for an elementary reaction, order is equals to molecularity, right? Can I say that for an elementary reaction, order is equals to molecularity, right? That we have seen the example also. Now, very important thing is that molecularity, very rarely molecularity will be 3, right? Or beyond that. Why? See, 2 molecules can easily collide. 3 molecules, 1, 2, third molecule will find it very difficult to collide here. So you have 1 molecule, you have second molecules. If 2 molecules are already colliding, third molecule will find it very difficult to collide. Fourth molecule will find it even more difficult to collide, right? So third, 3 molecularity is very rare. Beyond that, it's not possible only, right? So reactions having molecularity 3 or more are very rare and slow to proceed because that many collisions are very difficult, right? Okay. Now this is the difference in order and molecularity. The difference is that experimental order is experimental quantity. It can be 0, negative or fraction. Molecularity cannot be 0, negative or in fraction. Order is applicable to both elementary and complex. We have seen it. Molecularity we only defined for elementary reaction. It has no meaning for complex reactions. Rate determining step or order of the reaction, order of a complex reaction. That means rate determining step, as I told you. For a complex reaction, rate determining step, slowest step is the will define the order of the reaction. But molecularity of the slowest step is same as order of the overall reaction. That we have seen that for an elementary reaction, right, or for the slowest step reaction, molecularity and order are the same thing only, right? Okay. Now guys, this is the question. The molecularity of the above reaction is what? Is it 3, 5, 2, 1? See, molecularity cannot be 5. Molecularity also cannot, wait a minute, molecularity also cannot be 1. One molecule cannot collide with which one? One molecule also have to need some other molecule to get collided, right? So it's also not possible. 3 is also very rare. So only possibility is 2. So answer will be 2 is the correct answer here, right? Now guys, you have your homework here and I want you guys to do the homework. Let me see. I have my throat was totally blocked. Even then I was like, today I have to complete these all topics, right? I could have taken a very short lecture, but I took a long lecture. Reason being because I know that I want your syllabus to be completed on time. I understand you, right? And I want you guys also, why we are not taking one shots is that we know that it's very difficult in the starting. One shots are good for revision purpose, but in the starting, you should go on that pace that everything you understand get into your head and you get time to practice. So one thing is you should practice. This is the first question of homework that I have given you. Take the screenshot here. This is the second question. Which of the following can be order of reaction? Second question. Then this is the third question of homework. Everybody take the screenshot here. Take the screenshot. 3 questions I have given you for your homework. Let us see how many of you are able to answer these 3 questions or not, right? And second, I want you guys to tell me in the comment section, do you want DPP of solution chapter? Do you want DPPs of solution chapter? Like 20 to 30 questions set I'll give you for the solution chapter, the most important questions of that. But for that, you have to promise me that you will solve it, right? I'm not going to do hard work for you if you're not going to put efforts in that, right? So you also have to be very, very consistent and disciplined on your part, right? Okay, we teachers are disciplined on our part. We also want you guys to be disciplined because the aim, the main thing is to crack that exam, right? And guys, for that exam, right now at this point, we have like very, very important batch that is going on, that is DNA batch 2026, right? In this batch, right, the kind of content that we are providing you is next level because quizzes are being taken in the class, leaderboards are there in the class. That means leaderboard means quizzes will be done in the class, every single topic, Some questions I will solve, some questions I will give you proper time to solve it. Like I'll give you 50 seconds, 60 seconds, 1 minute. You know how students react on that. Some students, I'll show you that in when you will enter the DNA batch, we have proper data that this student is very in hurry to answer, but the speed is very fast, always incorrect answer, right? So that way we are able to tell the students that you are focusing on speed, not accuracy. That's how students are being improved in the batch, right? We especially mention the name, we tell the students that, okay, this is how to improve the speed with the accuracy. And now, trust me, I have seen that earlier, I used to see in the quizzes, correct answer was 60%. Now, I have achieved in some of the answers, some of the questions, students are giving 100% correct answer. Can you see from 60% to 100% correct? Yes, this they are doing in the DNA batch with the help of quizzes. That's the use of quizzes in the class, right? In the end, you get the leaderboard where you will get to see in terms of your competition what is your level, right? So that is beneficial. And there is no spamming that you can see on the YouTube. There is no spamming over there. We have the option to make our chats private. So when I'm teaching something, I always make my chats private so that only I am able to see your message. You are not able to see each other's message. This will help you not to get distracted in the class, right? When I want you guys to discuss with each other, I'll make the chats private. This is another benefit. I can unmute you and ask you the question. I have also talked to the students in the class when they are speaking, right? And that was amazing, right? That was amazing experience when I listen to your voices, right? That okay, this particular student that I used to see on chats, now I'm able to see, I'm able to listen to their voices, right? What exactly their question is. Sometimes we are not able to explain the question on the chat format. We can explain it on the mic format, right? This is what happens in the class. Now, what if you miss your class? You can watch the replay version. In the replay version, you can also ask your doubts, right? Then we are providing you mock tests after every 2 weeks. Mock tests are taken. Let's say this Sunday, students have their test, right? So already we have given them that this is your this is the syllabus that we are going to ask in the test. Syllabus is in those 2 weeks what we have covered in the batch. This is what we are going to take the test for in the mock test, right? Mock test timing is same as your NEET exam. It is conducted in the same time at the same timing, 2 to 5 in the exam. Same time is given to you, 180 minutes, 180 questions, right? After the mock test, we ask the students, right, what was the problem, right? A proper session. Also, we take that, okay, this is the problem. This is what they can tell us that, ma'am, this is where I'm lagging behind. Please tell me how to solve that, right? So these are some of the top things in the batch. Then for your more practice, we have Tattva modules test. That is the practice modules that we give you in which top level questions, previous year questions of AIPMT, of your AIMS, of JIPMER, AFMC are given to you, right? Then students, we also provide you these quick scanner cards, right? Okay, this is our quick scanner cards that we provide you, right? So all these things are there in the batch, that is at 4,999. So you can just click it over here and you will land up to the page and you can buy that course, right? And I'll wait for all of you in the batch because it's going extremely good. And now I think Baswa sir will be like, ma'am, please, I want to take the class as well, right? So guys, now I'll take your leave. Now you have your bio class. All the best for your bio class. Now I'll see you all tomorrow. And tomorrow is our class. Same chemical kinetics, first order, second order, third order reaction and nth order reaction. So I'll see you all at 8 p.m. in the tomorrow's class. Bye-bye. Take